Hello everyone, this is Neil from Edureka and welcome to this blockchain training session. Now without wasting any time, let's move forward and look at today's agenda to get a better understanding of what we'll be learning today. Now, since blockchain and Bitcoin system are extensively being used as a mean of transaction, we need to first try to understand what is the current existing monetary system and its various flaws. Because if a system is slowly being replaced by a newer system, there must be some issues with respect to that. Then we'll try to understand how can blockchain and Bitcoin help overcome the challenges that are faced by the current existing system, as well as what is a blockchain. Once we've understood this, we'll start deep diving by understanding the various blockchain concepts, as well as how a Bitcoin transaction takes place. Once you've understood how a Bitcoin transaction takes place, we'll move on to discuss the various blockchain features, as well as understand where blockchain is being used. Finally, no session is complete without a practical understanding. So what we'll be doing is we'll be doing a demo wherein we'll be creating Bitcoin wallets and we'll be transacting Bitcoins between them. So are you guys clear with respect to today's agenda? Can I get a quick confirmation? Okay, so I seem to have got a confirmation from Deep, Tyson, Ajay, Rahul, Shilpa, Stephanie, James, Frost. It's good to see that you guys are quite excited for this session. So let's begin by the first topic of today's session, that is the current existing monetary system. Now before we go into the existing monetary system, let's try to understand how the monetary system as a whole has changed over time. The first system that came into existence was the barter system, where you exchanged one kind of good with respect to the other instead of any fixed monetary as such. Then we had a universal ledger system where we used gold coins for exchange of goods. Now there was a certain value set for each good and then they would be exchanged with respect to gold coins. Then came the age of flat money. Here what we did was we exchanged paper currency which were cheaper than gold coins in exchange for any kinds of goods as required, and then came the age of digital banking. Now through online banking and digital banking, it became quite easy for us to purchase as well as sell our goods as per requirement. Now the current system that is existing and the one on which Bitcoins as well as all cryptocurrencies are based is the decentralized digital money. Now here you have a decentralized form of monetary system where not one single entity controls the governance of the money as such. We'll be talking more about the decentralized money system ahead, but right now I hope you guys have got a simple understanding with respect to the change in the monetary system. Okay, great. It's good to see that you guys are following. Now let's try to understand how trading actually happens with respect to current existing system. What happens is all the trades or transactions as such are kept inside a book. This book or ledger is offline wherein all the details are completely stored and only people who are associated with the bookkeeping can view this. Not anyone can view the book. Now to give you a simple example, we can only see the transactions that have been made by us or involved as part of our private accounting ledger. Now this is same as your banking report wherein you can only see all the transactions related to your account as such. For this reason, we actually trust a third party or a middleman to facilitate as well as approve all our transactions. Usually it's either a bank or a financial organization to which you're associated as such. Okay, but again, there are certain issues that are present with respect to the current existing banking system, and we'll be talking about few of them one by one. Now before I go ahead, can you guys give me a quick reply as to what do you feel is wrong with respect to the current existing system? Okay, so I seem to have started getting answers. It's good to see that you guys are being quite interactive. Now let me just pick out a few of them. Here I can see fake currencies. Yes, definitely that is one of the major concerns. High transaction fees with all transactions. Definitely that is one of the problems that most of us face. Because in today's monetary system, almost every transaction requires a certain added transaction fees. And not every one of us is comfortable paying that as well. Apart from that, I can also see bank frauds. Definitely that is another issue. So let me not go into that. Let's come back to our slides and let's see what we have here. Now the first issue is double spending. Now to those of you who are not familiar with what double spending is, double spending basically is a fraud that is part of the digital currency system. Here by using fake digital certificates, you can actually initiate transactions when you don't have sufficient balance. Apart from that, the chances of fake currencies being part of the transaction is also another major concern as we have seen as well. Then we also have the issue of standard transaction fees. Now let's say here Chandler is sending $10 to Joey, but there is a standard transaction fees of $2 that is associated with it. Now it may not seem a huge amount here, but let's say when you're dealing with a large transaction, then it becomes a problem as well. And if you look at the example here, According to SSN and CNN Money's report, in the year 2015, JP Morgan Chase, Bank of America and Wells Fargo earned $6 billion from just ATM and overdraft fees. Apart from this, the overall transaction fees collected in 2015 is estimated to be close to $42.5 billion. Now, that's a huge amount when you look at it. $42.5 billion from only just United States in 1 year. Now again, this is from different kinds of transaction fees, and these third parties as well as financial organizations make their revenue just like this. Another problem is the transaction delays. There is a certain delay with respect to every transaction that we make. Now let's say you're sending money to a relative in US, then again it takes about 2 to 3 days. Again, the earliest is almost 1 day, but then again there are certain additional transaction fees that you have to pay to get it processed faster. So the time delay that comes with respect to transaction is another major concern. Apart from this, one of the main concern when you're trusting a third party or a bank as such is the financial crisis. Now most of us might remember the 2008 financial crisis that had happened because most financial organizations had lent out their money as subprime mortgages to people who couldn't afford to pay them. This in turn led to a huge financial crisis where the value for real estate had dropped, and that led to almost $11 trillion worth crisis. Apart from that, you had close to 10 million people who went jobless with respect to that same. Now, this was a very huge number, and this was mainly because we had put all our trust into a third party and given them all our money, who in turn went and tried to get a profit out of this and caused a trouble for all of us as well. Now, these are some of the major challenges that are part of the current existing banking system, and let's try to understand how Bitcoins and blockchain help overcome these issues as such. But before we go ahead, I hope you guys are clear. Any questions still here? Okay, I see a lot more problems here, but let's not go into that right now as we have discussed. Let's keep these four itself in our mind and move forward with respect to that slide. Because any system that is there at present will have certain amount of flaws with respect to that. And as I had mentioned earlier, this is one of the key reasons why Bitcoin and blockchain system is so extensively being used as a parallel system for the monetary solutions. Okay, thank you, Frost. So moving forward, let's try to understand how blockchain and Bitcoins help solve these issues. Now, some of the major issues that we have talked in the previous slides are highlighted here. There's the centralized power system, there's the private ledger system, double spending, and prone to hack. So let me just summarize this once again. Now, centralized power basically means that one central authority governs the complete monetary system. Now, this could be a federal system or it could be a global system as well. One single authority controls all the power with respect to that certain monetary solution that is part of the existing system. Now, with respect to the private ledgers, as we have talked, every transaction that you make is only visible to you. The other transactions of those involved with that organization is not completely visible to you, and it's not completely transparent. Now let's say you are paying $50,000 to a bank. You're not completely aware who exactly gets this money and what exactly they're doing with respect to that same. Although it would give you some amount of satisfaction if you knew who exactly is this money going to. But again, if this system was available earlier, then I'm quite sure we could have avoided the 2008 financial crisis where subprime mortgages were lent out. Then comes the issue of double spending. As we have discussed earlier, double spending is an issue with the digital system where by using fake digital certificates, you can initiate transactions when you don't have sufficient balance. So let's say I'm sending every one of you $500, but at the same time I have only $200 in my bank. By creating fake certificates, then I can ensure that all of you get this money, and that exactly is the challenge of double spending as well. Finally comes the issue of prone to hack. Every now and then we have heard about how the accounts of certain people associated with a financial organization or a bank have their accounts hacked and certain data modified. This could be their money being transferred out, or this could be distributed somewhere else, and so forth. Now the first challenge of centralized power is getting hacked by using a decentralized power here. Blockchain system uses a distributed ledger system where anyone and everyone who's part of the system gets the access to the ledger and has the complete access and power with respect to the system as well. Apart from that, we follow a public ledger system here. All the transactions that are part of the blockchain are completely visible to everyone who's part of the blockchain. Then comes the issue of prone to hack. Blockchain system is completely immutable to hack, and no one till date has been able to modify or hack the system as such. Now, you might have heard about certain organizations which are associated to Bitcoin and blockchain getting hacked, but the core technology of blockchain has never been hacked as such. It's only the application built on the blockchain or the Bitcoin system that gets hacked as such. Apart from this, the issue of double spending was one of the key features that gets solved as part of the blockchain solution, because while building the blockchain system itself, this was kept in mind, and till date there has not been an issue of double spending as well. So are you guys clear with respect to how a blockchain and Bitcoin can help solve these issues? Any questions with respect to the same? Okay, so I seem to have a question here from Ajay. Ajay is asking me, if the ledger is public, can't everyone find the details with respect to the people involved in the system? Okay, Ajay, that's a very good question. So let me just address your question in this way. Since you're part of the blockchain system, only details that you get as part of the blockchain system is the transactional details. That is how much is being transferred from who to whom. But what happens is, even this data that gets transmitted is completely secure and encrypted. No one can actually decrypt this data and identify who is sending to who. We use a public key private key encryption system here, which we'll be talking ahead in the slides, but the identity of everyone involved in the transaction remains highly secure as well. Although there are certain blockchain systems that use account-based system, but Bitcoin blockchain system is something that does not deal with the account details as such. Here only the details with respect to the transaction is stored. Are you clear now, Ajay? Okay, good to see that all of you are clear. But still, there is one flaw that we have not talked about that is present in the current existing system, which gets tackled by the blockchain system. And this is the issue of transaction fees. In blockchain system, you either have to pay zero transaction fees or very minimal transaction fees. Now I'll be showing you how minimal the transaction fees is when we are transferring from our blockchain wallet to our personal wallet. But just to give you an idea, it's completely left to you. If you want to add a transaction fees, you can add. If not, you're completely free not to add as well. Some systems do add at times a minimal transaction fees, but this is very less when you compare to the actual existing system. Okay, so I have a question here from Shilpa. Shilpa is asking me, why should there be a transaction fees if the option of zero transaction fees is available? Okay, that's a very good question, Shilpa. Let me put it in this way. At a given instance, there are millions of Bitcoin transactions that happen globally. As I had mentioned, this is a distributed system that is spread throughout the globe. Okay, so at the given instance, there are millions of transactions that keep happening. So here you need to initiate a transaction which needs to be verified as well. So if you are attaching a fixed transaction fees with respect to your transaction, then what happens is your transaction is picked up on a priority. Now, although all transactions do get solved, but if you add a transaction fees, then what happens is your transaction is taken up on a priority level. Does that answer your question, Shilpa? Okay, that's great. Now that you've understood how the issues with respect to the current system can be tackled by the blockchain system, let's try to understand what exactly is blockchain. Now, blockchain is the core technology or the spine behind Bitcoin cryptographic system in itself. Originally introduced in 2009 by Satoshi Nakamoto as part of a white paper, the blockchain and the Bitcoin system was one of the key factors that led to the idea of decentralized digital currency system. Now, it was only in Jan 2009 when the first Bitcoin and blockchain system was implemented. Although it is still a mystery as to who Satoshi Nakamoto is, it is believed that he is a Japanese man who was born in 1974. But then again, these are just some of the rumors that are heard. But one thing is for sure, Satoshi Nakamoto is one of the most interesting men because he not only came up with such a complex system, he also holds close to 1 million bitcoins as part of today, and which is close to $2.4 billion. So that's a huge amount. And the mystery still remains. Apart from that, blockchain in itself is a technology which is a publicly distributed database. Now in these databases, what you're basically storing are encrypted ledgers. But then you might be wondering what is present in these ledgers. As I had mentioned earlier, now the ledger in itself actually holds a set of transactions which are verified and validated and have been completed after the previous block was created. Now every new block contains multiple transaction details. Now these transaction details again are hashed and encrypted and stored as part of a block. So every 10 minutes as per the current time, a new block gets created. And as you keep grouping up these blocks, it tends to become a long chain and it is called the blockchain in itself. Now, right now, even while we are speaking in this session, as per we're going in the slide itself, you can expect a new block to be created and the blockchain system to keep growing on as per the current standards. And once a block has been successfully added to the blockchain, the work on the new block starts and you keep building up the blockchain system. Now, moving on, let's talk about the three basic fundamental factors based on which blockchain system was built. The first is the cryptographic technologies. Here you use a public key private key cryptography to ensure that no one is able to identify the user, as well as you use various hashing functions which make the blockchain immutable. That is, you cannot modify anything that is part of the blockchain. Now, why does this happen? We'll be discussing a bit later. Now you might be still wondering, even though it is a public system, can I not make any changes with respect to this to make some money? And let me make this clarification right now. Even though it is just transaction details, even if you're trying to modify a small part of it, let's say even a single transaction if you're trying to modify, it does not get implicated as part of the blockchain. And this is mainly because of how effective the hash function is. Apart from this, we also use a peer-to-peer network wherein we maintain the ledger across every system which is part of the blockchain. This in turn completely ensures the consistency of the ledger. So let's say even if you're making a certain transactional modification in your system, this does not get implemented across the blockchain system because majority of the people who are part of the blockchain system actually have the original copy. And even if you want to make the modification system permanent as part of the blockchain system, you need to have at least 51% of the resource that is part of the blockchain system. Now, to make it quite simpler, now if you want to make a modification with respect to any data present in the blockchain, then you need to have more than 51% of the global resource associated to the blockchain. And as I had mentioned, blockchain is something that is distributed throughout the world and is something that involves millions of people. So imagine having more than 51% of the resource that is being used by millions of people. A huge number, right? And this is exactly why blockchain system is highly secure as well. Apart from this, the blockchain program in itself has various protocols which ensures that any tampering or any change with respect to the blockchain system is not allowed. So we'll be talking about each one of them one by one. Let's talk about the cryptographic technologies here. So as I had mentioned, you're using a public key cryptography here. Here basically you're going to use two keys. One is going to be private and the other is going to be public. Once you've encrypted your data using the public or the private, you can decrypt this data using the other. Now basically what happens as part of the blockchain system is that you send the details of the sender, that is you, as well as the receiver, along with the amount of bitcoins that has to be transferred. And this completely gets hashed to give you a specific hash value. Apart from this, there's also a digital signature, which is again a hashed value combination of your private key as well as the amount of bitcoins you're sending. So what you need to do is that you need to decrypt both these values and compare them. Once this is correct, then you can be ensured that this data has not been modified. And as I had mentioned earlier, this encryption is so secure that even if you change a specific semicolon or a comma that is associated as part of the key, then it makes a huge change with respect to the hash value associated. So there itself it identifies that this has been tampered and this transaction is not correct. Okay, then you have the peer-to-peer network. Now again, peer-to-peer network is the collection of different nodes associated in the blockchain system. Here you might be wondering what exactly is a node. Node is anyone associated with the blockchain system. It can be me, it can be you, but to give you a general idea, anyone who's associated with the blockchain system is called a node. Now there are different kinds of node and we'll be talking about them as part of the next session, but just to give you a simple idea, we are a complete node. That is, anyone who has the complete blockchain downloaded to their system and has the complete ledger as well is referred to as a full node. Apart from that, there are also special nodes called miners. Now miners are basically the people who validate our transaction as well as work on building a new block. Now remember the term of miner because this is something that is important and we'll be talking in the upcoming slides. Now coming back to our peer-to-peer network, let's look at the example here. Let's say A or Andy here identifies that there's a transaction between Bobby and Cindy where Bobby is sending Cindy 5 bitcoins. Now what happens is once he's identified it, then what happens is A broadcasts it to both B and C that has been verified. Bobby has enough balance to send it to Cindy, so you can go ahead with the transaction and I approve of this. Apart from this, once Bobby and Cindy have got the green signal, they in turn will transmit this verification signal across to all the nodes that they are connected to. And this keeps getting propagated throughout the network. So this is one of the major factors that helps when you're in part of a peer-to-peer network. You don't have to manually send it to every signal. When you send it to one specific node, they'll keep propagating it to all the nodes that they're connected to. Okay, clear till here? Any questions with respect to the first two factors? Okay, so I've got a question here from Deep. Deep is asking me what exactly was the digital signature. Deep, I'll come back to that. We'll be talking about that in the next slide. Don't worry. Okay, Ajay has another question here. Ajay is asking me what exactly gets propagated here. Okay, Ajay, so what gets propagated here is a digital signature telling everyone as part of the network that a transaction has been taken place and the ledger needs to get updated. That is, you need to deduct 5 bitcoins from Bobby's account and it has to be updated in Cindy's account. So that's exactly what gets propagated, and everyone who's part of the blockchain gets this propagation data. Okay, does that answer your question, Ajay? Okay, Ajay has another question here. Ajay is asking me, can I not modify this signal and propagate it? Okay, that's a very good question, Ajay. So let me clarify this. Okay, so let me take an example here itself. So let's say as part of the propagation, one of the nodes, in this case, let's say this node, I'll call it D and I'll call him Dave. Okay, so what Dave does is Dave gets the signal that Bobby has transferred 5 bitcoins to Cindy. Okay, now what he'll do is that he'll try to modify this. He'll try to make it such that instead of Cindy, it should go to him. That is, 5 bitcoins have to be transmitted to Dave instead of Cindy. Okay, now as you can see, there's already been a propagation that takes place. Now what he is trying to modify is the signal that is coming from Bobby. But at the same time, let's say here E, let me call it Eddie. Eddie has a signal. Okay, let's say Ajay, you're part of the blockchain, so I'll call this AJ. Then let me add Frost here. Frost is F. Okay, so what happens is D, he modifies. D is Dave. He tries to modify this signal that is coming to him and he'll send the updated signal to S, that is Shilpa here. Okay, so there's also been a signal coming from Dave to Shilpa. Okay, so this propagation takes place. This is the modified propagated signal. But then what happens is Shilpa gets two signals. One is coming from Ajay, okay, which has the correct data that is being propagated by Cindy. That is, 5 bitcoins has to be transferred from Bobby to Cindy. But at the same time, she's also getting another signal from Dave that says 5 bitcoins has to be transmitted from Bobby to Dave. Now this leads to a conflict. So what happens is she requires a clarification with respect to that same. When you look at the actual transmission, only Dave is the one who's got the modified transaction details. But everyone else who's part of the blockchain network has the correct details. That is, the transaction has to be between Bobby and Cindy and not anyone else. So what happens is this false transaction gets neglected. That is, this transaction gets neglected and the correct transaction gets stored as part of this ledger. Does that answer your question now, Ajay? Are you clear with respect to how it works out? Okay, that's great to see. So any other doubts with respect to how the peer-to-peer network works? Are you guys clear with respect to the same? Okay, it's good to see that you have followed till here. Now apart from this, as part of the peer-to-peer network, we use a distributed ledger. Now to help you understand how the distributed ledger works, let's take an example here. Now here what happens is Andy is giving Bobby $10, Bobby in turn is giving Debbie $3, and Debbie in turn is giving out Cindy $1. Okay. Now if you're storing this on a central ledger, there's just one copy and this is something that is not accessible to everyone. Let's say something happens to the central copy. Let's say it gets damaged, or if someone modifies this, then it becomes problematic. But if you're using a distributed ledger system, everyone who's part of the system has a copy of this, thereby in itself ensuring that even if the one copy present it gets corrupted or gets destroyed, there is no problem and everyone else part of the system has a copy. Even if, let's say, Andy loses his copy of the ledger, he can request it from Bobby, Debbie or Cindy. Or let's say Bobby doesn't want to pay back Andy the $10, he just tries to modify what is part of his ledger. Then, so Andy can check with Debbie and Cindy and ensure that the distributed ledger cannot be modified as such. So I hope you guys are clear with respect to how the distributed ledger system works, how it's better than the existing central ledger system. Okay, so I have a question here from Rahul. Rahul is asking me, can anyone actually download the distributed ledger for blockchain system? Definitely, Rahul. Now all you need to do is that you need to sign up to blockchain and then you can download the complete blockchain which has the complete transaction details back from 2009 till date. Okay, so this is completely accessible to anyone, and all the transactions which are part of the blockchain is completely viewable by the public. Does that answer your question, Rahul? Okay, that's great. So moving forward, let's try to talk about the digital signature. Now this is one of the major reasons which ensures that the transactions in itself cannot be modified or tampered with. Now what happens is you first feed the data, which basically has the public key of the sender, public key of the receiver, as well as how many bitcoins has to be transmitted into a hash algorithm. This in turn will give you a specific value of hash which you're going to encrypt using the private key. Once that gets encrypted, then you're going to add it as a digital signature to your document. Now, as we have discussed earlier, this document has the public key of the sender, public key of the receiver with the number of bitcoins and the digital sign network. Then you broadcast it across the peer-to-peer network, waiting for someone to verify this. Once you have broadcasted it, it is going to be received by a special node. What their job is to actually take the data present in the document, hash it, and as well as decrypt the digital signature and hash it as well. If the hash values that is obtained from decrypting as well as hashing the data present, then you compare these two hash values. If they are the same, then you can ensure that this is a valid transaction and has not been tampered with. So are you guys clear with respect to this, how this works out? Yes, Tyson, you can definitely decrypt using the private key as well, but what you need to do is that you need to encrypt it using the public key. So as we have discussed, this is an asymmetrical process. If you're encrypting using the public key, you can decrypt using the private key. If you're encrypting using the private key, then you can decrypt using the public key. Okay, that's great. So moving forward, let's talk about the blockchain program in itself. Blockchain basically was an implementation or a solution which ensured that the transmission of bitcoins can happen, as well as different decentralized cryptocurrencies can use the same solution to establish a parallel transaction system. Apart from this, blockchain concept can be implemented using any programming language that you wish, and blockchain originally was written using C++ and Java. Today has evolved into different programming languages. But again, the most popular and preferred programming language to write the blockchain program is Solidity, and this is one of the most secure programming languages as well. Okay. Now what we'll do is we'll try to discuss how a Bitcoin transaction takes place and what are the different steps involved in this. Before that, are you guys clear till here? Any doubts till here? Okay, James seems to have a question here. James is asking me, can anyone create a blockchain? Definitely, James. Now, if you've attended our previous session on blockchain tutorial session, there what we have done actually is that we have created a private autonomous blockchain and we have tried to execute a certain transactions as part of the blockchain. So you can check out our blockchain tutorial session to get a better understanding of the same. Okay, that's great. So let's try to understand how a Bitcoin transaction takes place. But before that, I'm quite sure all of you must have the question as to what is a Bitcoin. Bitcoin was the first decentralized digital currency introduced in the market. As I had mentioned earlier, it was Satoshi Nakamoto in 2009 who introduced the concept of Bitcoin and blockchain together. Another major thing is that it uses various cryptographic technologies to control its creation and management. Now, what do we mean by creation and management? Now, it is a digital currency. So you might be wondering, can't anyone just create it as per their requirement? The answer to that is no. To create a Bitcoin is not quite easy. It is not something that one single entity can do. Now this is mainly because the various cryptographic technologies and mathematical algorithms associated with creation of Bitcoin gets complex day by day. Now there is a limited number of Bitcoins that you can create, and that is being believed to be 21 million Bitcoins. Now what happens is that if we do not put this restriction on the creation and management of Bitcoins, then it becomes problematic and we over exhaust this. Now if there was no specific restrictions, then what would happen is maybe over the week, over the next week, or even today itself, people would have mined all the 21 million Bitcoins. And as on date, close to 14.5 million Bitcoins have been mined. It's only because of these restrictions with respect to the creation of Bitcoins has this process been decreased. Because every given day, there are new people who get involved in the creation of Bitcoin system, and the resources that are pooled in the Bitcoin creation system keeps growing day by day. So these controls that are being added to the creation and management are something that ensures that the last Bitcoin gets mined only by 2140. Are you guys clear? Okay, Shilpa is asking me, how do you keep control? Okay, Shilpa, to give you a better idea, there are a lot of mathematical problems that you need to solve, as well as you need to work with different algorithms. So the complexity associated with all this keeps changing on a regular basis. So over a fixed time, what happens is all the miners associated in creation of Bitcoins come together and decide on the complexity that needs to get modified. And this is something that is more like a democratic situation where everyone has a vote. So based on the vote of majority, the complexity is set and accordingly it is being planned. But as I had mentioned, with the growing complexity, it is believed that the last Bitcoin is only going to be mined in 2140. Does that answer your question, Shilpa? Okay, that's great. Now apart from this, all the Bitcoins are created and held electronically into a peer-to-peer open ledger system. That is, the Bitcoins, even though are created, are going to be held as part of the ledger system itself, and this ledger is completely peer-to-peer. Everyone who's part of the network gets a complete copy of this ledger, and this whole system, the whole system of peer-to-peer network, is known as blockchain. Finally, when we talk about the ledger in itself, this is something that gets produced by solving mathematical problems. So this is what I was talking about earlier. So you have to solve different mathematical problems to create a new block which has the complete transaction details, and that requires a different amount of resources. So again, it's not quite easy to create a new block or modify an existing block, and this in turn ensures that the ledger as well as the blockchain system is highly secure and immutable. So are you guys clear with respect to what is the Bitcoin? Okay, so Deep seems to have a question here. I like Deep's question. Deep is asking me, why does the value of Bitcoin change? Okay, Deep. So let's take it this way. If I have to speak statistically, in Jan 2017 itself, the value of Bitcoin was close to $1,100. Today, that is on 7th July, it's somewhere close to $2,800. Now this is mainly because of the belief that people put in a system. Now the more people invest into the system, the more the value keeps changing with respect to that same. So Bitcoin is something that runs around a no trust system where you don't need to put your trust on a third party, and is something that is governed by mathematical principle. Okay, so this in turn increases the value, and the more the number of people come into the system, invest their money and help the system grow, more will the value of Bitcoins and blockchain keep growing day by day. So does that answer your question, Deep? Okay, Ajay is asking me, can anyone purchase Bitcoins? Definitely, Ajay. We'll be talking about how you can purchase Bitcoin and from where in the demo part. There will also be seeing how you can transact using Bitcoins. So I request you to be a bit patient. Okay, Ajay? Moving forward, let's try to understand how a Bitcoin transaction takes place. Now let's take an example here where James has to send Kevin 500 Bitcoins. Okay. Now the transaction is something that's going to be part of a new block which is going to be validated by miners known as Lisa and Robert. So if you guys remember, we had earlier discussed about miners. So these are special nodes whose roles involve validating transactions as well as creating new blocks for the blockchain system. Okay, now what we'll do is let's try to look at the ledger in itself. So this is what a sample ledger looks like. Okay, every transaction holds the details of the transfer currency from one account to the other. That is, in the transaction details, what you'll be specifying is who is sending to whom, as well as how many Bitcoins are going to get transferred as part of this transaction. Okay, here you're not going to store the balance explicitly. What do I mean by not storing the balance explicitly? So let's take an example of your current bank account. Here what happens is there's a complete history of your credit and debit that gets processed, and then a current balance that is shown with respect to that same. However, in the Bitcoin blockchain system, you do not hold a balance sheet. But there are certain cryptocurrency systems like Ethereum which hold an account-based balance system, but Bitcoin blockchain system does not hold the balance explicitly. So you might be wondering, how do I know if a person has sufficient balance? So what you do is that you check the blockchain to see at any point does this person have sufficient balance to initiate this transaction. Let's say one of the transactions part of the blockchain is where someone else is sending James 500 Bitcoins. So that means I can be sure that he has enough balance to send it. So what you do is you check the complete transaction history that is associated with James to see if he has sufficient balance. Okay, are you guys clear? Okay, that's good to see. Now here what we'll do is that we'll consider the third entry that is part of the ledger to be James. So let me just add a J here. So this is James and this is Kevin. Okay, so as you remember, James has to send 500 bitcoins to Kevin. So what happens? 500 bitcoins should get deducted from James's account and has to get updated into Kevin's account. So once this transaction is validated, then the ledger also gets updated with respect to the same. So earlier where it was 1342 and Kevin had $12, it gets updated to 1842 and Kevin's balance gets updated to 512. Okay, so here explicitly balance is not stored. This is something that gets calculated every time the Bitcoin transaction gets recorded. Okay, this is just to give you a simple idea of how things work out as part of the blockchain system and how the ledger works. Okay, now to give you an overview of how the transaction as a whole works out is that first James initiates a transaction request. Okay, simultaneously miners who are called as special nodes try to validate this transaction. Okay, so whichever block has this transaction detail, they try to validate it. That is, does James have sufficient balance? And they both are basically trying to solve the same problem, so they are a race in between them as well. Okay, once they have identified that he has sufficient balance, that is the block gets validated, then the money gets deducted from James's account and gets added to Kevin's account. Now here what happens is, since each transaction has to get validated, this ensures that the problem of double spending does not occur. Okay, so even if he tries to falsify by sending two transactions, since each of the transaction gets validated one by the miners, the issue of double spending gets solved. Are you guys clear? Okay, so Tyson is asking me what happens if each of the miners get one of the transactions. That's a very good question, Tyson. So we'll take that up as part of the next session, where we'll be talking about how double spending gets solved as well as how a blockchain system validation takes place. So there we'll be talking about how the transaction gets validated in detail as well as how the problem of double spending completely gets annihilated. Okay? But since you have asked this question, Tyson, let me put it very simply for you. So what happens is that both of them actually validate one of the transactions, which is maybe 1 in a million case where both the transactions are verified and validated at the same time. And this gets created to a new block. Then what happens is they start to propagate it as part of the network. So that way everyone gets one copy of transaction that is being validated by Robert, the other by Lisa. Now whoever creates the next block, whichever block they have used previously, that is, if they have used Lisa's block, then the transaction approved by Lisa becomes valid and the transaction approved by Robert does not become valid. So this in turn eliminates the problem of double spending. I know it's not very clear. We'll be talking about it in the next session as I have mentioned. But I hope you've got a simple overview. Okay, that's good, Tyson. Now again, I expected this question from you as to why would miners actually validate these transactions. Now, we had talked earlier about a transaction fees, but in the blockchain system, the transaction fees is quite minimal. So validating a transaction in itself is not quite helpful. But for miners who create the new block, they get an incentive of 12.5 bitcoins. So if you create the next block of the blockchain system, you get an incentive of 12.5 bitcoins as part of a reward. So this in turn is a huge amount. So going by the present rate, this is somewhere close to $35,000 for just mining a new block. Easy way to make money, right? Now, it may seem a huge reward to just mine a new block, but it's not quite easy as you think. Given today's resources, no individual can completely mine a new block. Okay, so that's exactly why you come together to form something known as a resource pool, where different miners come together, form a group, and then try to solve the next mining block. Based on how much resource they have all put in to mine the new block, the reward gets distributed as such. So even if, let's say, 5 miners have come together and mined the new block, each get 2.5 bitcoins. Now when you say 2.5 bitcoins, this is close to almost $5,000 to $6,000. So that's quite useful, definitely. So as I had mentioned, given the individual resources, no single person can mine the new block as well. But the Bitcoin system definitely rewards you for helping out the transaction as well as mining the new block as such. Once the new block gets created, it becomes the permanent part of the blockchain, and as we have seen, the blockchain system keeps growing and new blocks keep getting added to it. So any doubts still here? Okay, so James is asking me where does this Bitcoin get stored. So James, you have a special wallet called a Bitcoin wallet which can be used to store these Bitcoins. Now, basically there are 4 different kinds of wallets. Now, I'm not going in detail right now. We'll be talking more about this as part of the demo. So basically you're going to use a special wallet called Bitcoin wallet to store these Bitcoins. So all you need to do is that you need to give the private key where the Bitcoins have to be transacted. Once you do that, you can get the Bitcoin reward once the mining is complete. So Deep is asking me, can I mine Bitcoins using my computer? Definitely Deep, but again, as I had mentioned, it's not quite feasible for a single user to mine a Bitcoin. Now there are a lot of things that you need to take into consideration. Okay, you need to take into consideration amount of electricity that you're going to be spending. You need to take into consideration amount of resource that you're putting. Okay, even the processor as well as RAM that you're investing in computing is another major factor here. So again, there are a lot of things that come into picture. So what I would suggest is you check out the Bitcoin feasibility calculator, which is available online, where you have to just enter certain details and then you can see how feasible it is for you to mine Bitcoins. But again, as I had mentioned, mining using your system is not quite feasible. Okay, you have special devices known as Bitcoin miners which are used for mining Bitcoins. Okay, Deep is asking me how is a Bitcoin miner different from our system. So to put it quite simply, basically is the difference between the processor. Your Bitcoin miner uses a specific kind of processor which makes it easy for you to solve the mathematical equation and mine the Bitcoin resource. Now I'm not going to go too much in detail with respect to this. We'll be talking about this in our next session where we'll try to mine Bitcoins using our system first and we'll try to mine it with using a Bitcoin miner second. Is that okay? Definitely. Great. Moving on, let's try to understand how a Bitcoin transaction takes place on a higher level. Okay, so what happens is someone actually requests for the transaction. So you can either send a transaction to someone else or you can also request a transaction. When you do this, it gets transmitted across the peer-to-peer network. That is, everyone who's part of the system gets the detail with respect to sender's public key, receiver's public key, as well as how many Bitcoins has to be transmitted. Once this gets validated, then this validation signal gets propagated throughout the network and it gets added as part of the new block. Once the new block gets added to the blockchain system, then it also gets verified and a transaction complete signal gets sent to the user. Okay, so I hope you guys are clear with respect to the flow of the blockchain system. Any doubts with respect to what we have discussed till here? Okay, it's great to see that you guys have followed till here. So now let's talk about the various blockchain features. Now in any blockchain system, all the transactions which are validated get included as part of it. Now the information here basically is the time at which the transaction is taking place, the date on which the transaction is taking place, the people involved. As I had mentioned here, the public keys as well as the amount that is being sent with respect to that same. All these information with respect to every transaction is stored. Again, you might be wondering how can you store so much data. So again, all of this gets combined and hashed to get a specific value which in turn gets stored as part of the block. Now each node has a complete copy of the blockchain. So as I had mentioned earlier, once you sign up for the blockchain network, then you can completely download the blockchain system, thereby ensuring you have a complete copy of the blockchain distributed ledger. Apart from this, as I had mentioned, miners are special nodes who verify all the transactions associated with the block by solving various mathematical puzzles. Now again, you might be wondering what this mathematical puzzle is and how is it solved. So for that, we'll talk about it in the next session, which completely deals with blockchain mining and blockchain verification. Also, the mathematical principle associated with blockchain completely ensures that all the nodes are automatically and continuously in a state of agreement with each other. That is, all the values which are present as part of the blockchain are same with respect to everyone who's part of the blockchain. So again, as I said, this is mainly because of the mathematical as well as cryptographic techniques involved in creation of a new block as well as verification and validate. So even if you try to modify one specific transaction or even a block as a whole, it is not quite possible because everyone who's part of the blockchain has the complete copy. So even if you try to change, it is not completely reflected. As we had seen our previous example when we are talking about the peer-to-peer network. Now, there are mainly 3 types of blockchain that can be implemented. The first is a public blockchain. Now here everyone who's part of the system can completely view the ledger as well as add a new block of transaction. That is, you can verify any transaction and add the new block. Okay. An example of this is the Bitcoin blockchain system as well as the Ethereum Dash and Fatcom blockchain system. Now these are different cryptocurrencies that are being used throughout. Then you have private blockchain. Now here the difference is that all the permissions, that is to either validate or add a new block, is kept to a central organization. Only people who are part of this organization can view and add transactions, but generally what happens is people in the internet are allowed to view this. But this is not the case always. There are certain organizational blockchain wherein you can't see it unless you have the required permission. So it's not completely accessible to the public as well. One example of this is multi-chain, and you also have Blockstack, which is another popular private blockchain. Then you have something known as a consortium blockchain. Consortium blockchain is somewhat between the public and the private blockchain. Here what happens is that the control is not completely restricted to one central authority, but with selected groups of nodes who have the access to either write or add a new block. But again, the ledger as itself is something that can be viewed by the public or can be restricted to people who need access to this. Okay, and examples for these are Ripple and R3. So depending on the needs, an organization can set up one of the three types. So who can give me an example of these three systems apart from what is mentioned here? You can take your time, think about it, and give me an example with respect to the three. Where do you think these different kinds of blockchains can be used? Okay, banks can be private and consortium. That's a good answer, Tyson. What do you think about a public blockchain? See, you don't need to restrict your thoughts just to the banking domain. Now, as I had mentioned to you, blockchain is something that is growing beyond the banking domain system as such. Financial monetary system is just a tip of the iceberg. There are different domains. Now, if I have to give you examples with respect to that same. So let's take an example of a supply chain blockchain. Here what happens is that you can establish a consortium or a private blockchain wherein only people who are on the governing board can decide to modify and this. But anyone who's associated to the blockchain can see the complete details. So even your suppliers as well as your demanders can actually get an idea of what is happening with the goods, where exactly it is, and which stage of the whole process is it. Now, one example of the same system is IBM's blockchain system, which has made a drastic change with respect to the supply chain market as well. And to know more, you can check out IBM's video on IBM blockchain, where you'll get a complete idea of how blockchain is being used by them. Now, another idea with respect to the consortium blockchain that I can give you is with respect to the healthcare system. So what few organizations are trying to implement is that they're trying to establish a consortium blockchain where people with selected access, mainly doctors, can view the complete records of patients which is present in the blockchain. So this ensures that if a customer is admitted in a different hospital, you don't need to completely send his record details across. He can directly access it from the blockchain given enough privileges, and it ensures that this is not completely tampered as well. So try to think about different domains where blockchain can be used apart from banking and the domains I have mentioned. So tomorrow when you come back for your next session, I hope you guys have a few answers at least. Okay? Definitely, that's good to see that you guys are interested. Okay, now moving forward, let's try to look at blockchain use case. Now, as I had mentioned, monetary system is basically just tip of the iceberg. Blockchain is something that is being used across different domains. Okay, now one major domain where blockchain presently is being used is supply chain management. Apart from that, blockchain is also being used for the election system. Okay, so here what is happening is that using the digital signature, anyone can sign into the blockchain and cast their vote, thereby ensuring more number of people come in and vote for their candidates, as well as vote frauds do not happen. Apart from that, these are some of the different domains where blockchain can be used. Let's say in terms of industry flows, you can change the way you interact with your suppliers. You can also identify your real-time capacity. You can even have a peer-to-peer trading system. So your network service management can improve, your demand side management can improve. Again, your self-service maintenance, your asset inventory tracking, all these are different domains where blockchain can be implemented to improve the efficiency as a whole. Now, as I had mentioned, your assignment for tomorrow is to identify at least 5 domains where you feel blockchain can be implemented and improve the existing system. Okay, so please do not pick up any of the domains that we have discussed as part of this session. Okay, that's great. Now let's move forward to the last topic of today's session, that is the blockchain demo. Now what we need to do is that we need to implement a digital transaction between different Bitcoin wallets. What we need to first do is that we need to set up one desktop wallet, that is Jax, as well as we need to set up one online Bitcoin wallet, that is blockchain. Once you've established these two wallets, we are going to perform a transaction between both of them, and then finally we'll verify. Okay. First what you need to do is that you need to set up your desktop wallet Jax. So for that, all you need to do is go to jax.io and download the digital wallet. So this is your Jax homepage. All you have to do is just click on Get Jax Free and you get redirected to the download page. Okay. Now here what you need to do is that you need to just select your device. Since I'm using a Windows system, I'm going to specify Windows and it's going to download. Now it's quite easy for you to install Jax. I'll be showing you how to install Jax as well. So first go ahead and download this wallet. Great. So now that you have set up your Jax wallet, let me just show you how to install blockchain wallet as well. So for that, just go to blockchain website and here just click on the option Get Free Bitcoin Wallet. Okay, so this is going to redirect you to a new page for signing up. So first start by giving your email ID, then specify a new password. So once you've specified your password, just click on I have agreed the terms and click on continue. So this in turn will give you a wallet identifier. Always store this number. So this is quite easy for you. What you need, all you're going to see is welcome. So your wallet is getting created automatically. So it's quite easy process. Okay, so now what we'll be doing is that we'll be initiating a transaction between my Bitcoin wallet to my Jax desktop wallet. Okay, so let me just show you how it's done. So as you can see here, there's a specific amount that's already loaded into my Bitcoin system. As to how you can purchase Bitcoins, there are different sites for you to purchase Bitcoins. Now if you are in India, there are different sites. I would recommend that you use either ZPay or localbitcoinbuyer.in. But again, as I had mentioned, you just need to Google up and you can find different websites that will help you purchase Bitcoins. Okay, now what we're going to do is that we're going to send this complete amount from my blockchain to my Jax wallet. Okay, so here you can either specify a request to receive amount or you can send it directly. So what I'll do is I'll send it, and what is going to ask me is that it's going to ask me the private key. So for that, come back here, you can copy this from here and just paste it. So now let's say I need to specify the amount. Okay, so what I'll do is I'll specify the complete amount that I have, that is 0.12, and then immediately it tells me what is the maximum fees I can send. So just click on it and this is the maximum fees that I can send. Now if you see, the standard transaction fees that is added to this is just 4 rupees. Okay, I'm sending almost close to 2600 and it's asking me a 4 rupees transaction fees. So this helps you identify it better. Okay, apart from this, let's say if you have to perform this transaction on a priority, then you have the option of setting it on priority. But that means I have to again reset it, and then here you can see that the estimated time also changes. This gets confirmed between 0 to 60 minutes and is taking again a transaction fees of 41 rupees. So it's not much when I consider the standard transaction fees that banks take. Okay, so what I'll do is I'll set it on priority and I'll initiate this transaction. Okay, just click on send bitcoins and the transaction is being processed. Come back to Jax and let's wait. Now if you see here, the transaction has been added and my Bitcoin wallet has been updated with respect to that same. But there's one thing here, it tells me that this transaction is not confirmed. That is, there's a specific time that it takes for it to get confirmed. So this has to be verified and validated and has to get added to the blockchain, and only then will this transaction get confirmed. So again, as we see, this had been set as a priority and it may take somewhere close to 1 hour at max to get confirmed. Now this is just the maximum situation. There are times where it gets confirmed instantaneously as well. Okay, so let's just keep waiting. Now one thing you can do to check the status is to go to this arrow mark here and you can see 3-block confirmation is still pending. So to get more info, just click on this and you'll get redirected to the page which gives you the update with respect to the status. So here you can see it requires 3 confirmations with respect to that same and it's still not yet confirmed. So if you click on view tree chart, it will show you how the transaction is being converted and how it has to get verified. So let's wait for the final confirmation and then let's conclude the session. Okay, so if you see here, the transaction has been confirmed, and if you check in Jax, you can find the Bitcoin wallet has been updated with respect to that same. Okay, so let's go back to our slides and let's conclude this session. We first talked about the current existing banking system as well as the various issues that were there, as well as we talked about how Bitcoins and blockchain system can solve these issues. Then we moved on to talk about the various blockchain concepts and how blockchain can help you achieve the solution to this. Then we talked about Bitcoin transaction as well as the various blockchain features, and finally we saw a use case and a demo on blockchain transaction. So any doubts with respect to today's session? Any questions that you would like me to answer? Okay, seems like you guys are quite clear with respect to today's session. Thank you for attending this session. Hope you have a great weekend. Thank you.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!